Hey guys, today's lesson we're gonna start it by doing problem number 11 from the chain rule. Someone asked me to do it because of uh, something about the answer, and I checked the answer, and I saw that the first answer that you get is the correct answer. I don't know how they got the second one. I put it in the calculator, and that's the same answer I got with the calculator. Okay, so the first thing we do is bring down the 1 4. So 1 over 4, and then copy the whole thing. Negative 5x cubed plus 1 to the minus 3. And then I have a minus 5. And then subtract 1. So when you subtract 1, you get negative 3 over 4 times the derivative of the inside. Notice that here we have another chain rule, so we bring down the negative 3. And then you copy the same thing. Negative 5x cubed plus 1. And then subtract 1, that would be to the minus 4. And then the negative 5 doesn't have a derivative, but because this is a chain rule, you need to take the derivative of the inside, which is negative 15x squared, and then close it. Okay, so uh, this is it's not the final answer, because we can still multiply the negative 15 with the negative 3 and then times 1. So negative negative, that's positive. What is that? 30, that's 45, right? Yeah, so 45. And then you have an x squared that is at the top. And then over, you see this 4 here. So we put the 4 on the bottom. Okay, here's the deal. Look, you see how this is on the bottom, and this is kind of how can I say it? Okay, look. So I know this whole thing is gonna be on the bottom because this is negative. But you see how this one is negative too? But you know what? Let me just do it like this. So I'm going to get negative 5 x3 plus 1. This is still negative because it's the inside. Okay, and then this is 3 to the 4th. Okay, you cannot change both at the same time because this one is inside. So you have to do this one individually. And then you have, this is also on the bottom. So times, remember the 15 and the 3, they went away with the 1. They're right here with the 45. And then this would be negative 5x cubed plus 1, and then quantity to the 4th. Okay, so yeah, you can leave it like this. The other thing that I was going to tell you is that you see how this is negative 3 to the negative 3, so you can put it as 1 over this. Let me just do it. So this would be the final answer, 45x squared 4 times 1 over 5x cubed plus 1 quantity cubed minus 5 to the 3/4, and then negative 5x3 plus 1 to the 4th. So this will be the final answer. Cool? So this and this is the same. This is negative. You already have it on the bottom, but it's still negative. So to make it positive, you need to bring it as a denominator on the bottom. So you just put a 1 on the top because there's nothing there. Cool? Alrighty. So that's that. Now we go to the new lesson. Are you guys ready for this? This is something that everybody loves. You wanna see? This is called derivatives of trig functions. Everybody loves trig functions. Before I start, with the derivatives. We need to remember something from trig, which are the ¿cómo se llama? The properties. If you have sine, I'm gonna say sine x over cosine x is the same thing as tangent x. That's just a property. The same goes with if you have 1 over sine x is the same thing as cosecant x. If you have 1 over cosine x is the same thing as secant x. Okay? And then this one, if you flip it, cosine x over sine x, that's equal to cotangent x. Okay? And then you can play around with these things. Like, for example, this one here, if you flip this too, it's still the same thing. So you can get 1 over cosecant x is the same thing as sine x. And so on. So if you flip this one, 1 over secant would be equal to cosine. How do I know this? Look, this is the easiest way to memorize these things. How you can flip them around is this. Look, let me do it here on the bottom. Look, what is 10 divided by 2? It's 5. Okay. What is 10 divided by 5? It's 2. Now if you get this one, what is 2 times 5? It's 10. What is 5 times 2? It's also 10. So you see? So if you multiply the bottom number times the one on the other side, you get the top. So 2 times 5, 10. 5 times 2, 10. So that means that these two numbers can be flipped. Okay? So you can have the 2 on the bottom and the 5 on the other side, or you can flip them and have the 5 on the bottom and the 2 on the other side, and you still get 10. Same here. So if you multiply sine times cosecant, you get 1. The same thing as if you flip them, cosecant times sine will give you 1. Okay? So you'll see later why we use it, because sometimes it would be easier to use this one if you're given this one. Okay? Sometimes it's gonna be easier, like if they give you 1 over cosecant, you can just change it to sine. That's why this is important. Okay? Alright, let's move on. So remember, what we just did has nothing to do with derivatives yet. So these are the derivatives. We're starting the derivatives right now. This is a table that you have to memorize. When we put d over dx, that means the derivative of sine x is cosine x. Okay? Oops. So d over dx, that means the derivative of sine x is equal to cosine x. So you have to memorize this one. And then we have d dx, the derivative of cosine x is equal to negative sine x. And then we have, let me put it here, the derivative of tangent equals to secant square x. The derivative of secant x equals to secant x times tangent x. So secant x tangent x. What am I missing? Sine, cosine, tangent, secant. Let's see. The derivative of cosecant x is equal to negative cosecant x, cosecant x cotangent x. And then the last one will be the derivative of cotangent x. Do I have it here? I don't have it here, but the derivative of cotangent x is negative cosecant square x. Okay? So this you have to memorize. If you don't memorize this, there's no way that you can do the problem. Cool? Okay, so let's do the problems. So example 1. So if you have y equals sine x, the derivative would be cosine x. Okay? That's simple. How do we know? Because we know the rule. The derivative of sine is cosine. Okay? And then the same goes for all of the other ones. So the problem is when you have something inside here that is something other than x. Let me see if I want to do that right now. Yeah, I do. Okay. Look, I'm going to make this up. Example 2. Imagine if I have the derivative of sine, and then I have x cubed. See, on this sine x, we don't put the parentheses because it's just the x. On this one, just so we don't get confused, this is sine x cubed. Now, you need to understand that sine cube of x is something different than sine of x cubed. Okay? This one means that you have a sine x and you cube it. And this one means that you have sine and inside the sine you have the x cubed. Okay? So you need to understand. Oh, and the reason why we put the 3 right here in the sine is because it looks way cooler than if we put it here. Okay? But this is the same thing. That's what we mean. Okay? Okay, so when we take the derivative of any of the trig functions that have something inside other than just the variable, meaning just like x, you need to do a chain rule. What does that mean? Look, so you know how we said you copy the same thing? So in this case would be the derivative of sine. You take the derivative which is cosine, and then you copy the same thing, which is this. Okay? But then, after you copy this, you need to take the derivative of the inside. So the derivative of x cubed would be 3x squared. Okay? And then just to look, just for this to look prettier, you bring this to the front. So 3x squared, and then cosine x cubed. So this would be your derivative. Okay? Now let me explain it again. So pretend you have nothing there. So that's the first thing you're gonna say. You're gonna see. So you're gonna say the derivative of sine. Okay, I know the derivative of sine is cosine. So you put the derivative. The derivative of sine is cosine. And then you copy what you have. Now, if you have something else here, an exponent, a number in the front of the letter, anything like that, you need to take the derivative of the inside. Okay? Once you take the derivative of the inside, you bring it to the front. You know this is a multiplication, right? So you bring it to the front because it looks cool. That's it. Now let me do another one. Look at this one. And I'm using sine because that's the easiest one. What about if we have sine 2x? Again, do we have something other than x? Yeah, we have 2x, so that's different, okay? So that means that I have to use the chain rule inside the sine. So what is the derivative of sine? Cosine, okay? Cosine. Cosine of what? Well, 2x, okay? Now, take the derivative of the inside, which is 2x. The derivative of 2x would be 2. So you see how ugly this looks? So just move the 2 to the front. So now you have 2 cosine 2x. Okay? Piece of cake, right? Now let me do one that I have here. This one looks kind of interesting. This would be example 4. This one is saying, so find the derivative of sine, and then they have pi over 2 minus x. Okay? Now, a lot of people get confused with this, but look, it's the same thing. Okay, so pretend that's not there. What is the derivative of sine? Cosine, okay. So y prime equals cosine. Copy that. You see, you're almost done. So you just, the derivative of sine is cosine, you copy the same thing, and you take the derivative. Now, here's where people get confused. What is the derivative of pi over 2? Well, the derivative of pi over 2 would be 0, because pi is a number. So this means 3.14 divided by 2. There's no variable there. So that's 0. So the only one that you need to take the derivative from is negative x. So the derivative of negative x is just negative 1. Okay? Cool? So now the derivative would be negative cosine and then pi over 2 minus x. Cool? Okay, let's see what I have. What else? Okay, so here's an example. So this one says, example 5, find the derivative of sine x over cosine x. Remember, anytime you have a division, we will need to do the quotient rule. Do we want to do the quotient rule with this? No, we don't. But guess what? I already know from the rules that sine over cosine is tangent. So sine over cosine is this, is the same thing. Notice that I'm not saying this is the derivative. I'm saying this is the same. Okay? Now, do I know what the derivative of tangent is? Yes, I do. What is the derivative of tangent? Well, it's secant squared. You see how easy that is? Okay? Let's go to example 6. Now I have another one. It says, find the derivative of cosine x over sine x. Well, I know that cosine x over sine x is the same thing as what? Cotangent. Okay? Do I know the derivative of cotangent? Yeah, I know it is negative cosecant squared x. Cool? Let's do examples. I'm gonna go like this. Example 7. Let's see this one. Oh, there's one here. Y equals 1 over cosine x. Again, see, when you have something like this, this is a division, so you either bring it to the top as a negative exponent or you do the quotient rule, but we don't want to do that. But we remember, because we study and we memorize, that 1 over cosine is the same thing as secant x. This is the same. I'm just gonna put it here. Same thing. Okay? So this thing is the same thing as this thing. Okay? So why would I bother doing this if I already memorized the derivative of secant is secant tangent? Oops, y prime is equal to secant x tangent x. You see how simple that is when you memorize things? Okay? Just for fun, I'm gonna do another one. That would be the next one. So this one is y equals 1 over sine. So 1 over sine, I remember, is cosecant. Okay? And I know that the derivative of cosecant is negative cosecant x cotangent x. And I'm done. Okay? Isn't that so beautiful? But wait, there's more. Okay, I did one like this. Oh, here's one. Okay, example 9. This one says find the derivative of y equals cosecant. Wait, understand. No, let me do this one later. This one is y equals secant x squared. Secant x squared. Okay? So now, remember this? Anything other than x, we have to take the derivative of that after you take the derivative of the trig function. So you can just put your finger, cover it. What is the derivative of secant? Well, the derivative, oh, it's right here, look. The derivative of secant is secant tangent. Okay, so I know that y prime is going to be secant. Here, we don't put secant x. We're going to put secant of this. So secant x squared, and then I need tangent x squared. And now that I'm done, the derivative of secant is secant tangent. Of what? Well, of that thing. Okay? Now, I need to take the derivative of the inside. What is the derivative of the inside? 2x. Okay? Again, just to make it prettier, you put the 2x all the way in the front. So 2x secant x squared tangent x squared. Okay? So that would be the answer. Cool? Okay, now the one that I got confused, this is y equals cosecant x cubed minus 5x. This is the one that I was gonna do here. Okay, again, oh my god, I don't know how to do it. It has to cover it. What is the derivative of cosecant? The derivative of cosecant is negative cosecant cotangent. Okay, negative cosecant of what? Well, this thing. Okay, let me write it down. Am I done? No, because the derivative also has a cotangent. Okay, let me write it. Cotangent. Cotangent what? X? No, cotangent of the whole thing. Okay, x cubed minus 5x. Am I done? No, because we have something other than x. Now we need to take the derivative of the whole thing. The derivative of x cubed would be 3x squared, and the derivative of negative 5x is negative 5. Okay? Again, we don't like to have this because it looks kind of weird or confusing, so we bring this to the front. But look at this one. You see how this one has a negative, so you put the negative outside, and then you put the parentheses. So 3x squared minus 5, and then you copy the whole thing besides that. So cosecant, sorry, x cubed minus 5x, and then cotangent x cubed minus 5x. Okay. See, the answer is exactly the same thing. The only thing we did is we moved this to the front. And the negative is from the formula. Cool. I think this would be one of the hardest problems, but let me see if I can find a more difficult one. Oh, let me do this one. Y equals cosine of the square root of 3x. Can you guys see? Let me move it up. So y equals cosine of square root of 3x. Oh my god, this one has a square root. Forget about it. Close it. Cover it. y prime. What is the derivative of cosine? The derivative of cosine is negative sine. Negative sine what? Well, this thing. Am I done? No, because I have something other than x. What does that mean? I need to take the derivative of the inside. But guess what? Remember, anytime you have a square root, change it. This would be 3x to the 1/2. Okay? So look. So this is the inside. So when you take the derivative of this, you actually have to use the chain rule to take the derivative. So the derivative would be 1/2, copy the same thing, subtract 1, take the derivative of the inside. Okay? So now look. Did I do this right? Yeah, the derivative of the inside. Okay. Now, let me simplify this. I'm going to do it on this side here. And then, so I can just write the answer. Look, this 3 goes at the top to the, multiply the 1. So you got 3 over 2. This goes to the bottom because it's a negative 1/2. And you can bring back the radical sign. Okay? Okay, so now this is gonna go, this simplified. So this goes to the front, but you have a negative. So put it in front of the 3. So y prime is equal to negative 3 over 2 square root of 3x, and then, oh, and the sign goes at the top, sine, and then square root of 3x. Okay? No, you cannot cancel this. Anytime you have something inside a trig function, see, this square root of 3 is part of the sine. Now, let me just do it here. Sine of 3x. Oops. You cannot cancel this. This you can cancel. You see what I mean? This square root of 3x is by itself. So when you have something by itself and the same thing is on the bottom, you can cancel it out. This one is part of it. It's part of the sine. So no, you cannot cancel this. Okay, so this will be our final answer. Cool? Let me look for another one. Oh, this one looks fun. Okay, so if we can do this one, if you guys understand this one, then that means that I did my job. This would be the hardest problem. F of x. What was it? Example what? 12. I always forget what example I'm doing. It's just a number. Okay, f of x equals tangent x plus 1. Okay, you see how terrifying that looks? Well, look, cover it. Do you know the derivative of tangent? Yeah, the derivative of tangent is secant squared. F prime of x, secant square of what? Well, the whole thing. Okay, copy the whole thing. I'm good. What else do I need? Well, I need to take the derivative of this. Oh, okay. So let me do it here. You see how this is a division? So that means I have to do use the quotient rule. F prime g minus g prime f over g squared. Okay. The derivative of f would be 1. Let me just write it. Copy g, x plus 1. Can you guys see? Yeah. Minus the derivative of g is 1. And then copy g. And then x plus 1 quantity squared. Okay. Now simplify. This is x plus 1. This is minus x. And then you have x plus 1 quantity squared. So you see you have x and negative x, they cancel out. So you end up with 1 over x plus 1 quantity squared. Cool? Okay, so that goes here. 1 and then x plus 1 quantity squared. Are we done? No, remember, we need to put this in the front. So f prime of x equals, oh, we can actually put it, let's see, no, it's gonna look weird. Okay, so we just bring this to the front, 1 over x plus 1 family square times secant square of the whole thing, x over x plus 1. See how crazy that looks? Cool? Okay, I think I'm done. So I'm gonna post the link for the exercises. Okay, let me know if you have any questions.